So a unit ratio is when we make a ratio compared to 1. Now this is something that we've actually dealt with before, and it's very important actually because it is our same as a unit multiplier or a multiplying factor. Okay, so when we find out our unit ratio, this is very important because we can use this to solve other problems. So for example, the Vancouver Canucks here have lost 52 games and had 30 wins in the 2016-2017 season. So they weren't very good. So we can find a unit rate for this case by dividing. That's how we find any multiplier. To find any multiplier, we divide. Okay, that's a very important principle. So here, if I just take 52 losses and divide it by 30 wins, okay, I end up with 1.73 losses for 1 win. Okay, and this is really just a rate, okay, but now it becomes a unit rate, and that unit rate is a very useful multiplier for lots of problems. So we get this unit ratio 1.73 losses for 1 win. Okay, so let's try this on some problems then. So here we have 54 free throws made for 77 free throws attempted. Okay, so I'm going to divide those two numbers to get my unit rate. So when I divide, I get 0.70 free throws made for 1 free throw attempt. So this becomes my unit rate. Okay, so here I can say I have 7 cups of flour to 2 eggs. So I have 3.5, instead of I divide, I get 3.5 cups for 1 egg. Now, the one thing about these unit rates is that the unit rates actually can go either way. So when I do these unit rates the other way, we get slightly different rate. The numbers are different, but the ratios are exactly the same. So if I try 77 divided by 54 free throws, so I need 1.42 attempts for every free throw made. Okay, now although it looks different, the number is different, the ratio is exactly the same. Here, instead of 3.5 cups per egg, I can actually divide 2 eggs by 7 cups. And I end up getting 0.285, so I'm just going to round that to 29 eggs for 1 cup. So for every 1 cup, I only need that fraction of an egg. Okay, so unit rates, we find unit rates by dividing. They are our multiplier and divisors in our rate problems. And we have to be clear on the direction because we can write our unit rates in either direction. Okay, we can use, in this case, free throws to attempts or attempts per free throw. And those are the same rates, but just in different terms. So let's try a couple of these problems. So we have a problem here where we have a triangle. Okay, so we know that, and I don't know if I drew this very accurately, but I have 1 part, 2 part, 3 parts as my angles. Oh, sorry, this is not 1, 3, 4, but it's going to be 2, 3, and 4 parts are my angles. So I don't have very much to go with here, although I do know that the total angles of a triangle add up to 180 degrees. So I really need to kind of incorporate that somehow in my ratio. So I'm going to do this. So I have 2 parts, 3 parts, 4 parts to 9 parts total. There's my total. Okay, and what I do know is that my total degrees is 180 degrees. And since I now have a connection between these two, I now can find a multiplier here. Okay, so once I have compared two terms of the ratio, okay, the other terms can be compared with that same multiplier. So my multiplier here becomes times by 20. So what ends up happening then is I can just use that same multiplier to solve my problem. Okay, two parts. Well, one part is I can find my unit rate. In fact, let's do that since we're doing unit rates. I'm going to do 180 degrees divided by 9 parts gives me 20 degrees per part. Okay, well that means then each part is 20 degrees, so I multiply 2 times 20, I get our 40 degrees here. 3 times 20 gives me my 60 degrees here. 4 times 20 gives me my 80 degrees, and this adds up to my 180 degree triangle. So there it is. This is going to be 40, 60, and 80 degrees. So that total part was implied. Okay, so sometimes you have to read through the problem and we can imply some parts of that ratio. For here we have a 30 kilogram bag of fertilizer. It's labeled 15, 20, 10, okay, which means that it contains 15% nitrogen, 20% phosphorus, and 10% potassium by weight. So there are other parts because you can see that that does not add up to 100%. So we want to know how many kilograms of nitrogen, phosphorus, and potassium are there in the bag. Well, what have we been given? What does that 30 kilograms relate to? Well, I have nitrogen, phosphorus, okay, is 20%, and potassium, and the symbol for potassium is K, so I'm going to use that, the chemical symbol is K, so I'm going to use 10, or sorry, K for that. Now, the 30 kilograms doesn't go with any of these. In fact, it goes with the total. And the total is going to be our 100%. Okay, so that 30 kilograms relates to 100%. Okay, so if that's, I now have this proportion that I can compare, and I can work out the multiplier here. So I can do 30 kilograms divided by 100%, which gives me 0.3 kilograms per percent. 1 for 1%. Okay, that's my unit rate. Okay, that's my multiplier. That's, again, when I divide like this, I end up with a unit rate or a multiplier here. So I can times by 0.3 to go from that top row to the bottom row. Well, that means then I'm going to get 10% times 0.3 is going to give me 3 kilograms. Okay, 20% times 0.3 is going to give me 6 kilograms. Okay, 15% times 0.3 gives me 4.5 kilograms. Okay, so we're going to have 4.5 kilograms, 6 kilograms, and 3 kilograms, and the rest of it that make up the 30 kilograms, I think it's about, what would that be? 16.5 kilograms is going to be filler. Okay, so there it is. There's our how we can use it. We have more than a two-term ratio, but still, as long as we can find a comparison, we can find our multiplier.